Agroecology is both a science and a practice that applies ecological principles to agricultural systems. It focuses on producing food in ways that work with nature rather than against it, emphasizing biodiversity, soil health, and resilient farming landscapes. Instead of relying heavily on external inputs, agroecology seeks to design agricultural systems that are productive, environmentally sustainable, and socially just. At the core of agroecology is the understanding that farms are ecosystems. Soil, plants, animals, microorganisms, water, and people interact continuously within agricultural landscapes. Healthy soils are central to these interactions. By increasing soil organic matter and biological activity, agroecological practices improve soil structure, nutrient cycling, and water retention. This creates conditions where crops can thrive with fewer external inputs. Biodiversity plays a critical role in agroecological systems. Diverse cropping systems, including intercropping, crop rotations, and agroforestry, reduce pest and disease pressure while improving ecosystem stability. Different plant species occupy different ecological niches, allowing more efficient use of sunlight, water, and nutrients. This diversity enhances resilience to climate variability and reduces the risk of total crop failure. Agroecology places strong emphasis on ecological nutrient management. Rather than depending primarily on synthetic fertilizers, agroecological systems rely on organic matter inputs, compost, manure, cover crops, and biological nitrogen fixation. Soil organisms transform organic inputs into plant available nutrients, creating a closed loop nutrient cycle that reduces losses and environmental pollution. Pest and disease management in agroecology is based on prevention and ecological balance. Healthy soils and diverse plant communities support beneficial insects and microorganisms that naturally suppress pests. Instead of routine pesticide applications, agroecological systems use monitoring, habitat management, and biological controls to maintain pest populations below damaging levels. Agroecology also integrates social and cultural dimensions of agriculture. It values farmers' knowledge, local adaptation, and community participation. Smallholder farmers, indigenous practices, and traditional knowledge systems are often central to agroecological approaches. This focus on people ensures that agricultural systems are not only environmentally sound, but also socially sustainable. Water management is another key component of agroecology. Practices such as mulching, contour farming, and diversified cropping improve water infiltration and reduce runoff and evaporation. By improving soil structure and organic matter, agroecological systems enhance the soil's ability to store water, helping crops withstand droughts and irregular rainfall. Agroecology contributes to climate change mitigation and adaptation by increasing soil carbon stocks, reducing greenhouse gas emissions from inputs, and building resilient landscapes. Diverse systems are better able to adapt to climate extremes, making agroecology a valuable strategy for climate smart agriculture. While agroecology is sometimes seen as low tech, it does not reject innovation. Modern tools such as soil testing, remote sensing, and data driven decision support can strengthen agroecological management when used in harmony with ecological principles. The goal is not to replace nature with technology, but to support natural processes intelligently. Agroecology represents a shift from input intensive agriculture to knowledge intensive farming. By designing systems that mimic natural ecosystems, agroecology offers a pathway towards sustainable food production, healthy soils, resilient communities, and long term environmental stewardship.